Hi everyone, in this lesson we'll be practicing solving trigonometric equations, and our goal is to isolate the trig function using algebraic techniques and then solve using our unit circle. So for each of these examples we're going to find solutions that exist only in the interval from 0 to 2 pi. Example 1, we have 2 sine x minus 1 equals 0. If you treat this equation as if it said 2x minus 1 equals 0, how would you solve for x? You would isolate it by adding 1 to both sides and then dividing by 2. The same algebraic properties apply here. When we do this, we're left with sine of x equals 1/2. So how do we solve for x? Well, we use our unit circle. So you're asking yourself, which angles on the unit circle from 0 to 2 pi are the y values, or the sine values, that are equal to 1/2? Sine is equal to 1/2 in two different places, and that happens at pi over 6 radians and at 5 pi over 6 radians. So our two solutions to this equation are x equals pi over 6 and 5 pi over 6. In this next example, we see that sine of x occurs twice, so that's our clue to combine like terms. And we're going to use normal algebraic properties here. We can add sine of x to both sides, giving us sine of x plus sine of x, and then we can subtract the square root of 2 on both sides, which would give us 2 sine of x equals negative square root of 2. Now dividing both sides by 2 to isolate the sine, we get sine of x equals negative square root of 2 over 2. So again, we have to refer to that unit circle. Looking at where the y values are negative square root of 2 over 2, we have two angles where this occurs. So the two angles where sine is equal to negative square root of 2 over 2 is at 5 pi over 4 and at 7 pi over 4. So these are your two solutions. Let's try the next example. We have 3 tangent squared x minus 1 equals 0. So we'll add 1 to both sides and divide by 3, giving us tangent squared x equals 1/3. To isolate the tangent, we take the square root of both sides, and we get tangent x equals positive negative 1 over the square root of 3. So just a quick reminder, tangent is equal to sine over cosine. So again, using our unit circle, we're now trying to decide which values, if we do sine divided by cosine, aka y divided by x, will give us positive and negative 1 over the square root of 3. So there's two angles where this happens, at pi over 6 and at 5 pi over 6. So at pi over 6 and 5 pi over 6, if we divide sine by cosine, or y by x, we will end up getting 1 over the square root of 3. It's positive for pi over 6, and it would be negative for 5 pi over 6. So our two solutions would be pi over 6 and 5 pi over 6 on the interval from 0 to 2 pi. This next example, we have two trig functions, cotangent and cosine, and the cosine is squared. So I'm going to set everything equal to 0 here by subtracting 2 cotangent x on both sides, because that will allow me to factor to potentially solve this equation. So notice, once I have subtracted 2 cotangent x, I have a common cotangent factor here that I can factor out, and I can rewrite the problem as cotangent x times cosine squared x minus 2 equals 0. So now we can use the zero product property to set each of these factors equal to 0, and then we can solve for x. Remember, cotangent is equal to cosine over sine, so referencing our unit circle, that would be x divided by y. The only place where cosine over sine will equal 0 is at 90 degrees, or at pi over 2. So for that first part, cotangent x equals 0, I know that the only x value there would be pi over 2. Now looking at the next equation, cosine squared x minus 2 equals 0, I'm going to solve this by adding 2 to both sides and then taking the square root. And so we end up with cosine of x is equal to positive or negative square root of 2. There is no angle on the unit circle for which the cosine, or the x value, will give us positive or negative square root of 2. So there's no solution there. The only solution is pi over 2 for this equation. In example 5, I see multiple sine terms, which clues me in that I should probably set this equal to 0 and try to factor. It's already equal to 0, so that's good news. Now let's review factoring quadratics. If this simply said 2x squared minus x minus 1 equals 0, could you factor 2x squared minus x minus 1? It would be 2x plus 1 times x minus 1. The same exact factoring properties apply for sine of x. So we can factor this quantity into 2 sine of x plus 1 multiplied by sine of x minus 1. Now we can just set each factor equal to 0 and then solve. So doing this, we get sine of x equals negative 1/2 and sine of x equals 1. Yet again, referencing your unit circle. Which angles will the sine value be equal to negative 1/2? This happens in two places, at 7 pi over 6 and 11 pi over 6 radians. And then, for which angles will sine of x be equal to 1? Well, this occurs in only one place from 0 to 2 pi, and that's at pi over 2, or 90 degrees. So my three solutions for this equation on the interval from 0 to 2 pi would just be pi over 2, 7 pi over 6, and 11 pi over 6. All right, this is our last example for this video. So notice in this example, we have two different trig functions, and I have a sine squared. So I'm thinking a couple things here. First, I would like to set this equation equal to 0. So let's subtract 3 on both sides, and now we have 2 sine squared plus 3 cosine minus 3 equals 0. Since I have these two different trig functions, I want to try to use a technique where I write one of them in terms of the other. And I can do that because if you remember your trig identities, there's a Pythagorean identity that tells me sine squared is also equal to 1 minus cosine squared. The Pythagorean identity states sine squared plus cosine squared is 1. So we can just rewrite sine squared as 1 minus cosine squared. Now that we've rewritten this in terms of all cosines, we can combine like terms, simplify, and see if we're able to factor. Distributing that 2 and then taking care of 2 minus 3, our new equation would now say negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. But that negative 2 bugs me. So we're just going to go ahead and multiply both sides by negative 1 so that my leading term is positive instead of negative. So now my equation will say positive 2 cosine x squared minus 3 cosine x plus 1 equals 0. So now we're going to go ahead and revisit that idea of factoring quadratics. Replacing the cosines with x's, we would have 2x squared minus 3x plus 1. Well, you can factor that. It's 2x minus 1 times x minus 1. So apply that same concept but with a cosine, and we get the factors 2 cosine x minus 1 multiplied by cosine x minus 1 equals 0. Now we can use the zero product property and set each of those factors equal to 0. Isolating cosine for both of these equations gives us cosine x equals positive 1/2 and cosine x equals positive 1. So again, how do we find x? We just have to reference our unit circle. So we're asking ourselves, what angle will cosine of that angle give me 1/2? In other words, where on the unit circle will I have an x coordinate of 1/2? That happens at pi over 3 and at 5 pi over 3. And where will cosine give me 1, an x coordinate of 1? That's just at 0 degrees or 0 radians. So my three solutions for this final example are 0, pi over 3, and 5 pi over 3. That's it for this lesson on solving trig equations. Thanks for watching.